All right, the next practical deals with the conversion of benzoin to benzene. Now, the question they ask is what is the role of HNO3 in the conversion of benzoin to benzyl? Now, HNO3, okay, let's come here and solve that. That is question 1. Now, HNO3 is the oxidizing agent because this reaction actually deals with the oxidation of benzoin to benzyl. So HNO3 is an oxidizing agent. Now next, what other reagent can be used in place of nitric acid? Now in place of nitric acid, this is question 2. What other reagent do you think you can use in place of nitric acid? You can use copper 2 acetate. You can use magnesium nitrate in acetic acid. Now most times these two things are actually preferred as compared to HNO3 because of the toxic fumes from HNO3. Now the next question you can actually give here is give the equation of reaction. Question number 3. So we have question 3. Give the equation of reaction. Now the equation of reaction is between benzoin to benzylic acid. It's an oxidation of the secondary alcohol. So first of all, what is benzoin? This is the structure of benzoin. This hydrogen, this OH, this double bond O, something like this. This is what benzoin looks like. You can draw it any way you want to draw it. You can decide to bring this OH down and bring this H up. Whichever way you want to draw it is actually correct. Now this is oxidized with an oxidizing agent HNO3 to so here become double bond, here's another double bond. It's still the same thing. All right, so here is what we call benzene. This is benzoin, this is benzyl, then this is nitric acid. It's just an oxidation reaction. Now give a brief background of the experiment. So we have question 4. Now what is the brief background of the experiment? First of all, you weigh certain amount of benzoin into a round bottom flask. Most of this experiment they are use round bottom flask. Plus then you have add nitric acid. You may not even give the exact amount. And reflux the mixture in boiling water bath. Reflux in boiling water. See the same process for all of them. All right, Then filter the product and wash with cold water. After this, you filter and wash with cold water. After washing with cold water, what do we then do? Then you may recrystallize to purify it. Recrystallize the product form with methylated spirit. Dry, weigh, and characterize it by calculating the melting point. All right, the percentage purity and the melting point. So that is that for that one. Now, we've been talking about crystallization. You may be surprised that tomorrow they will just bring it to you, to your face. What is crystallization? Now, actually, crystallization is a separation technique, all right, that involves separation based on solubility at different temperature. It's a separation technique that involves separation based on solubility at what? Different temperature. Usually, solubility increases with what? Increasing temperature. Are you getting it? So as it cools down, solubility will decrease, and then you are going to form the what? The precipitate. So crystallization is the process by which a substance transitions from a liquid or gas to a solid, forming a crystal structure. It is commonly used in chemistry to purify substance or produce crystals with specific property. That is what crystallization is. Is that okay? That is it. So crystallization is like the process of forming solid crystal. Like I told you, it's based on difference in what? The solubility at different what? Temperature. Now, all these reactions are condensation reaction. They may ask you, what is condensation reaction? A condensation reaction is a reaction that involves two molecules coming together to form a larger molecule. For instance, the benzaldehyde to form benzoin is a condensation reaction. Now, I say calculate the percentage purity if 5 grams of benzoin was used and the actual yield is 3.0. We are given the actual yield 3.0. This is benzoin, this is benzene. What was the mass of benzoin we calculated the other time? We said benzoin is 212 gram. That's the mass. Why benzyl? If you calculate benzyl, you agree with me that if benzoin is 212 gram, benzyl is like you remove 2 hydrogen from benzoin. So benzyl will be, if you remove 2 hydrogen, what is the mass of 2 hydrogen? 210 gram. I believe that is correct. But you can decide to calculate, you can calculate their masses, their molecular masses, by counting the various atoms present there. Is that okay? So it's 210. Very, very correct. So we can say that 212 gram of benzoin will give us 210 gram of benzyl. Therefore, 5 gram, because if you check the question, told you that 5 gram of benzoin was used. Therefore, 5 gram of benzoin would be equivalent to what? To unknown. That's what we are looking for. So at this point, you cross multiply, because you know this will cancel this out. So what are we going to be left with? We are going to have 212 times x is equals to 210 times 5. So we divide both sides by 212. This will cancel this, and then our x would be equals to, so we have 210 times 5 divided by 212. 210 times 5 divided by 212. What is that going to give to us? 210 times 5 divided by 212. That will give us 4.95 gram of benzyl. So this will form our theoretical yield. They say find the percentage purity if the actual yield is 3.0. How do we calculate actual yield? 3.0. What is percentage purity? Actual yield 3.0 over theoretical yield 4.95 times 100%. What do you think the percentage purity will be now? 3 divided by 4.95, 0.6 times 100%, which is 60.6. So this one gave you 60.6% weight by weight. So that is that for this particular question. Any other one? No. Now the next thing you actually asked to do, I don't know if I should just do that one here. They are the uses. You should know each of the uses of each of these things you are actually synthesizing. All right, then I believe the next practical is, all right, so that is that for this particular one. We'll see in the next one.